Welcome to our esteemed teachers and art lovers who are watching us now. We are happy and excited to give you information about our International Mathematics Education Conference, ICOME, hosted this year by Yildiz Technical University in Istanbul. So, who are we?
As the ICOMA family, we aim to bring together national and international mathematicians and mathematics educators by providing a forum for keynote speeches, panel discussions, and paper presentations at our annual conference.
For the first 2 years of its organization, ICOMA was a face-to-face conference. But 2020, due to the COVID-19 pandemic that imposed restrictions of assembly on the whole world, we adopted a virtual format, which was attended by 200 participants from 19 different countries, representing a steady rise in participants since the first year.
This year, as ICOMA and ICOMA families, we will hold our conference online on May 26 and 29, 2021, two separate programs in mathematics and mathematics education.
The language of the ICOMA Mathematics Education Conference is English, and this year's theme is integrating of the new educational approach to the mathematics education.
Our program features 4 invited speakers from different countries who are well-known experts in their fields, and 8 panelists participating in 2 panels, which we call Online Teaching and Learning and STEM Education Approach. We are looking forward to interacting with colleagues in the world of mathematics education on topic of vital interest to those engaged in the teaching and learning of mathematics.
All math educators, we anticipate lively and informative exchange of ideas in the field of mathematics education, as new ideas are formed and different perspectives are entertained.
If you also want to present your paper at your conference, be sure not to miss the application deadline. You can follow the application and registration processes on our website calendar. Also, do not forget to follow us on our social media accounts.
You can share next video, Mehmet.
Okay. Turkey introduction video, right? Yes. Sorry.
Do you hear me? This is the voice of an embryo past, the sound of horses and the strong walk of men. Do you feel me? This is your cultural thrill, the smell of a powerful land. Can you see me?
Dear participants, we welcome all of you to the 2021 International Conference on Mathematics Education. This conference is supported by students and graduates of Purdue University, Indiana University Bloomington, Yildiz Technical University, Agri Ibrahim Cecen University, and Kirsehir Ahi Evran University. The International Mathematics Education Conference is designed for academicians, graduate students, teachers, undergraduate students, and parents interested in teaching and learning mathematics. As the ICOME, we aim to invite mathematics educators from various countries to share their points of view on various mathematics topics, to create new perceptions on mathematics education, and to evaluate and examine different teaching and learning approaches. This year, the conference theme is decided as A New Age and Its Challenges, integrating new educational approaches into education. We, as a mathematics education community, know that despite the current challenges, it's essential for any society to continue to progress by strengthening and developing new educational programs. Therefore, in this critical period time, it's important for mathematics educators to discuss new opportunities, approaches, and challenges emerging in the field of mathematics education and how to integrate new educational approaches into mathematics teaching and learning. Our main aim in this conference is to create a global network by forming respectful and beneficial relationships between all the participants in a productive atmosphere. We are happy and proud to host you at this online conference. I welcome all of you again and wish you a very productive time throughout the conference. I leave the word to our conference chair, Associate Professor Yusuf Zeren from Yildiz Technical University for the welcome speech.
Thank you. Dear Professor, doctors, students, and all our participants, welcome our international conference on mathematics and mathematics education. We are pleased to have held the fourth edition of our conference as an electronic conference, namely e-conference. Although we cannot host you here physically, we are extremely happy to see you in this digital environment and to know that you are healthy. First 2 years, we organized in-person conference at our university. Unfortunately, because of the pandemic, last year we decided to bring two lovers of maths together in a conference, and this year too. I would like to express my belief that this conference, which we have created after a hard preparatory period with our college who have spent great effort, will contribute to you. This year, we have two separate programs, mathematics and mathematics education. There are 15 keynote and 8 panelists, in total 23 invited speakers. And also we have 250 participants who have made valuable works in the interdisciplinary fields of mathematics and mathematics education from 25 different countries this year. I would like to thank all of program organization and scientific committee members for their contribution to our conference. I wish you a good conference. Thank you very much.
Thank you to our chair, Yusuf Zeren, for this welcome speech. I leave the word to Vice Rector Ayşe Banu Karadağ from Yildiz Technical University for the welcome speech.
Are you okay?
Yes, I'm okay. Sorry.
Dear guests, I would like to welcome all of you today to the International Conference on Mathematical Advances and Applications and International Conference on Mathematics Education, if I'm not mistaken. This conference is organized for the fourth time at our university, and I hope this conference will be fruitful for all the participants today. If I'm not mistaken, we had two first conferences at our campus in 2018 and 2019. Unfortunately, I'm not an expert of mathematics. I am an expert of social sciences, but I know and I believe strongly in maths. I know that maths is all around us in everything we do. It is the science that deals everything with the logic, with quantity and arrangement, and even in my domain, in literature, in translation and interpreting studies, I know I need maths because maths and language don't seem to be disciplines. Academics know this, I am sure. Maths and language don't seem to be disciplines as separate as you might imagine them to be. And during this difficult pandemic period in which we are passing through exceptional times, as Yildiz Technical University, we have taken exceptional actions to preserve, let me say, our top place in online education as a research university. Shortly and finally, let me say that we could not have accomplished this conference without you, without your help and support, especially the help and support of the members of the organizing committee. I would like to thank especially Professor Yusuf Zeren for his invaluable support and his speech today. Once more, I would like to express my warmest welcome to nearly 200 guests from 24 different countries. Let me say, Murat Hocam, 24 different countries.
Yeah,
you say.
correct.
With that, I would like to welcome once more all of you on behalf of the Yildiz Technical University, on behalf of organizing committee, and I strongly believe that both the presentations and the following discussions will pave the way for broader horizons in related fields. I wish you shortly a productive, successful sessions, and most importantly, healthier days during this pandemic period. Thank you all and best wishes.
Okay, thank you to our Vice Director for this beautiful welcome speech too. Now I'm going to leave the word to Selim Yavuz for explaining the conference program.
You welcome all our participants. Before we start our first keynote speaker speech, I would like to share the program and just give you general information about the programs and Zoom links. And after that, we will start our first keynote speakers in this Zoom links. You don't need to go other links for that, you just need to wait. And I'm sharing the program. This year we are organizing in 4 days program, and it starts, in our program we have 2 time zones. You can check in Turkey time zone and United States Eastern time zone and the dates. And we have also Zoom links for each parallel sessions and presentations. You can see, you can follow. And each parallel session has Zoom host and chair. Chair will lead for academically in the parallel sessions, and also if you have any like technical supports, Zoom host will help you for that. They already send an email to you for your Zoom links, but if you want to attend Zoom our other parallel session, you just need to click the Zoom links with this parallel session. For example, in part 1, parallel session 1, if you want to attend this presentations, you just need to click these links. But if you want to change, you need to sign out for these Zoom links, and you need to click other one. We have specific Zoom links for each parallel session, so you need to change your links and you need to enter again for each parallel sessions. And we have breakout rooms. I'm not sure for now we have time for after invited speaker speech for breakout rooms, meetings rooms, but after that one, after parallel sessions, we will have 10 minutes break rooms. And it is also, we are organizing in online, unfortunately, so we don't have enough time to meet and to networking for all of us, but we created 10 minutes break rooms, and you can join this via these links, and you can talk with other colleagues about for meetings. And also today we have our panel session at 1:20 p.m. to 2:20 p.m. for United States Eastern time zone, and 20:20 to 21:20 in Turkey time zone. And if you want to join, you can click just these links. And we will also share our YouTube online live video for our panelists, and there will be other participants can follow, like students and parents will follow these panels. And for the second day, we don't have a panel, but we have invited speakers in 5 p.m. In Turkey time zone. And also we have a social meetup. In that social meetup, we will share like a Puyana recital and Ney recital, which is famous in Turkish culture. And also it will be online game. And we are trying to enjoy that part. It will be starts tomorrow as in parallel for panel sessions time. And also third day, we will start again in our keynote speakers. It's 5 p.m. in Turkey time zone. And we will have some parallel sessions. You just need to click that links. Any parallel session you can access. There is no postcode required. You just need to click the links. You can attend. And also third day we have panel 2 is STEM educational approach, and you are welcome to join us. And this will be also again YouTube live video, and parents and students will join from the YouTube, and maybe they can ask question, and you are welcome to join. And the last day of conference, we will have 4th keynote speaker speech, and then end of the day we will have closing ceremony, and we will prepare for video demonstration of our conference. During the conference, we will take some screenshot and video parts, and we will share. Last year we did, it was awesome, and I hope this year will be again soon. And the closing ceremony will be together ICOMA Mathematics Conference and ICOME Mathematics Education Conference. And we will discuss the conference review, and we will decide for next year, and we will talk. You are welcome to join, all of you. I give my words to our chair, Kirsehir Ahi, and we can start for our first invited keynote speaker speech.
And thank you, Selim. And good afternoon, everyone. Welcome to our international online conference on mathematics education. First, let me introduce myself. My name is Kirsehir Ahi from Kirsehir Ahi Evran University. And now I am seeing some friends from United States. Welcome. Good to see you, Lane. It was good for us. And I'm chair for this section and for our first keynote speaker. And dear Professor Adnan Baki will be with us. And first, I want to introduce him to you. The Professor Dr. Adnan Baki was born in 1960 in the district of Konya in Trabzon. He graduated from the Department of Mathematics Education in Faculty of Education of Yildiz Technical University in 1978. He completed his master's at University of New Brunswick, Canada in 1990. Then he started his doctoral studies at University College London in England. He completed his doctorate and Ph.D. at the Institute of Education, which ranked first in the field of educational sciences in the world rankings. After completing his doctorate in 1994, he returned home as Turkey's first math education doctorate. Since then, he has tried to do many things that need to be done in the name of mathematics education, and to say many things that need to be said. He worked as a consultant between 1996 and 1998 within the scope of the Higher Education Council, World Bank, National Education Development Projects. In 1996, he became Turkey's first associate professor of mathematics education. He became a professor in 2004. Since 1995, he has held many academic and administrative positions at Fatih Faculty of Education. Between 2010 and 2013, he was the Dean of Fatih Faculty of Education. In this institution, where he worked as a lecturer and researcher, more than 45 doctoral dissertations were completed under his supervision. He has 5 books, as well as over 100 articles published in national and international indexed referred journals in the field of mathematics education. The 1001 TÜBİTAK projects has been completed, awarded by TÜBİTAK in 2012 as an exemplary project. He is the editor of the Turkish Journal of Mathematics Education. As a chairman of the organizing committee, he organizes the International Symposium of Turkish Computer and Mathematics Education every 2 years. He is also the honorary president of the Mathematics Education Association. He is currently working as a lecturer and researcher in Fatih Faculty of Education, Department of Mathematics and Science Education. His area of interest is information and communication technologies and teacher training in mathematics education. And the dear professors, before I leave my work, the Dr. Adnan Baki, Professor Adnan Baki, I want to remind some important points. Please mute your audio, your microphone during presentation. And if you have any questions, we will have the question and answers section. We expect the Professor Adnan Baki to talk about 40-45 minutes. Then we will have 10 or 15 minutes for questions. Please note your questions to ask him. And thank you very much for coming again. And dear Professor Adnan Baki, thank you very much for accept our invitation and being here. Now we are ready to listen to you. Thank you very much.
Thank you, Kürşat, for your introduction. Hello, dear participants. First of all, I would like to thank the organizing committee for inviting me as a keynote speaker in this conference. I wish the conference to be successfully completed as intended. As you see, today I am going to talk about the social construction of mathematical knowledge from theoretical and practical perspectives. All of us, you know, Piaget, when we mention, when we deal with the construction of knowledge, we know, we remember Piaget. Piaget, as you know, Piaget is the pioneer of radical constructivism. He emphasized individualized learning. And we know this explanation about adaptation process belongs to Piaget, while individual construction of new knowledge, individual or learner or a student is happy with his or her current cognitive situation. I mean, it is in the he is in the balance. When he encountered with new situation, then the balance will broken, and as Piaget called this situation as a disequilibrium, cognitive disequilibrium. This construction again deny the behavioristic assumptions and epistemologies. For Piaget, or for radical constructivism, knowledge is not directly transferred from known to unknown. It is actively established or constructed by the individual, depend on his existing cognitive structure or current cognitive situation. In this process, the learner makes a conscious choice depend on his current cognitive state, actively makes an effort to make sense of the new situation and try to accommodate the new situation. When the circle is complete, the individual construction completed, but this instruction is objective, is true, or is valid, we don't know. We don't have any guarantee for that. In order for learning to be functional and permanent, the student should actively participate in the process of creating his own knowledge. Radical constructivism suggests this for us. It seems that there is no any problem with Piaget's explanation in here. However, as a result of this circle, will the student individual interpretation, ideas, or any construction, thought, decision, and the action to be taken as a result of this adaptation will always be socially objectively correct, beautiful, useful, aesthetic, and ethical. We don't have a guarantee of this. In the philosophy of mathematics, the absolutists, we call absolutists, say that mathematics is not time independent. Mathematics universally consists of objective set of knowledge. But unlike the absolutist, mathematics depend on time, history, and language. Of course, when we are saying this, we are not making an overgeneralization. We do not deny that there is universal mathematical knowledge in mathematics. Like you can say Pythagorean theorem, it is not depend on us. It existed before us and it will exist after us. Therefore, in here, what I would like to say that mathematics contains information related to human, time, history, and language, apart from such knowledge, which is the main characteristic of today's mathematics. What I would like to say that the displacement of objectivity, I mean, discussing the idea, negotiating the mathematical ideas and interpretations, and agreeing on them. This is the main activity of today's mathematics. Therefore, in this construction of mathematical knowledge is the main part of today's mathematics. Of course, this is not a very convincing case for absolutist mathematicians who believe that real power of mathematics is individual construction and its abstractions and its objectivity. At this point, social constructivism comes into play. I wonder if the mathematical knowledge is similar to the knowledge that child construct through dialogue with adults. Let's look at Vygotsky's definition of the social construction of knowledge. Everybody, I think, knows the zone of proximal development. This explanation is similar to Piagetian explanation. In both of them, there is a level, current students' current mathematical level, and then a new situation to be reached, and to be learned. If this zone of proximal development is decided correctly, then learner can reach a new situation through using scaffolding. Someone provides clues, intermediate solution, and data. In here, all conversation, Vygotsky emphasized language in this process, but all conversation that take place during learning and teaching not always affect the individual construction of mathematical knowledge. In order to create strong scaffolding in this process, it is important that the learner and teacher are competent in mathematics and cognitively comprehend the ideas spoken on, and not take the conversation out of logical consistency and mathematical validity. Otherwise, conversation between teacher and student or other students, conversation became a verbal language game of mathematics. Of course, we should point out some requirements in this process. For example, such as there is a direct relation between the logic of language and reality. Random language is not used in this process, in the learning and teaching process. Mathematical correctness is linguistic in the nature. According to Wittgenstein, the limits of language are also the limits of mathematics. Therefore, mathematics is a language, but is not a random language. For Vygotsky, for example, one should be concerned not with the truth of fallibility of a theorem or proposition, but with its meaningful and or absurdity. Therefore, if we do not know the meanings of the word we use during this process, we cannot discuss any subject efficiently. Therefore, language alone is not enough to understand mathematics. For example, we all speak Turkish. Right now, I am trying to speak English, but my mother tongue is Turkish. We all speak Turkish. However, this doesn't mean that we understand each other easily. For that reason, similarly, mathematics is a way of thinking, makes abstraction about quantitative and qualitative situation or objects. In doing so, it uses its unique language. Therefore, mathematics is a universal language. Since we cannot all speak this language properly, like our mother tongue, it becomes difficult for us to understand each other in the mathematical world. Of course, although it is difficult to agree on this language, we do not yet have any useful tool to describe and to understand the universe. So far, we developed a useful tool to understand universe, to describe our feelings. It is the mathematics. Instead of trying to understand abstraction using this language on our own, we can understand it better when we are involved in social interaction process, where meaning are discussed, negotiated, and shared. As Vygotsky said, when language and social interaction go together, cognitive development take place in there. We can remember the Karl Popper. Karl Popper explained the other things from subjective knowledge to objective knowledge. Karl Popper describes the process of using language as scaffolding in the process of Vygotsky's social interaction and transformation of individual subjective knowledge into objective knowledge. According to Karl Popper, the individual has three different interconnected three different worlds. First one is our network, our own world. The second one is a world around him, in which try his own ideas and test them. The third one is the social network or mathematical world, and consists of experts in that field. I will try to give this. I will try to explain this schematic explanation of paper with using mathematics, and how we can construct objective mathematical knowledge. Let me explain the Popper's model for mathematics. The new ideas first come from the first world, our mind. The new ideas that come into mind when a person is doing mathematics are not yet objective mathematics knowledge or real mathematical knowledge. In order for these ideas or works to be transformed into mathematical knowledge, they must be built in logical consistency by the community of mathematicians and negotiated and agreed upon by this community. This process, as Lakatush says, maybe I am talking about the philosophy of mathematics, and I suppose that you know Karl Popper and Lakatush. For that reason, I am using their names directly. The process, in this process, as Lakatush semi-experimental approach, you know, as Lakatush said, is realized through dialogues, discussion, and negotiation that mathematicians will carry out on these ideas. The ideas must be transformed into a formal mathematical language. This process of doing mathematics is the same as for learning mathematics. Therefore, individual understanding that occurs during learning do not always create correct conceptualization or correct objective mathematics knowledge. In here, Lakatush argues that mathematics is a cultural practice. We can say that students make sense out of mathematics knowledge cannot be separate from the structure of cultural practice and their history of meanings. Classroom cultures in the form of a daily practice provide the environment in which students come to know and understand mathematics in a formal setting. Therefore, the social dimension of objectivity, objective knowledge, is based on the use of language, rules, and meanings embedded in the culture and lifestyle. Therefore, the objectivity of knowledge is possible through sharing culture by community members. What I am trying to say here shortly, social constructivism as a cognitive theory and as an epistemologic approach and as a learning theory tell us all of them. I would like to mention the other constructivist, we call it constructionism, rather different than constructivism. This word first time used by Seymour Papert. Seymour Papert, he is also Piaget's student. He worked MIT, and he goes one step more step further than social constructivism and introduced constructionism. Papert uses the word constructionism to explain how learning and meaning occur during communication and interaction between individual and community. Constructionism focuses on how ideas and attitudes develop over time in the context of the social community. Pepper says here that if the individual constructs his own self-meaning, it will be more difficult to comprehend a complex concept verbally or in writing. In here, his ideas against the Piagetian individual construction of knowledge. For Papert, if the student builds something that others will see and others will criticize and perhaps use this creation, then he or she concentrate more on it and becomes more deeply individualized in the learning process. I mean, deep learning takes place in the process of creating a product and then sharing it. Collaborative environment are required here. I would like to say, to share my, for example, right now, up to now, I'm dealing with the theoretical perspective of social construction of knowledge, but let me try to make some concrete examples from our teaching experiences. I would like to share one of my experiences with prospective teachers during my lesson, mathematics teaching class. I asked my students this question: why does the product of two negative numbers get positive? And then I asked if you could explain, try to explain and try to give an example in mathematics. And then I divided them into groups and I gave them enough time to work. Then after group work completed, and I expected good answer from them. No real mathematical explanations emerge from their group work, except for a statement. Everybody know this example, you know. The enemy of my enemy is my friend. After that, I tried to give some helping information to them. And I said, let's simplify this question like this. You can think -1, and you can think that -1 times -1, what will happen? And after this arrangement, I will show them these cartoons. Minus time minus will be positive, will be written like this, will be known like this, and nobody will say why it is correct. This cartoon is like that, and then I started a conversation like this. Everybody knows that in addition operation, this is the inverse property in addition operation, and we know this. Then how can we continue to do something? And I asked them, you know, the associative property of multiplication on addition, and then together we decided to multiply both sides, -1 plus 1, multiply both sides -1. Then I asked them, you know, zero property in multiplication operation. Then everybody says, okay, this will be 0. The other side will be like this. And then again I asked them, what was this? The identity property of multiplication. Then this one will be 1. So at the end we have this equation. And we add, again we have this one. Again we add one both sides like this. Okay. Again, this will be 0. Then we get this one. This is maybe a simple example, but this shows us how we can create a common and meaningful product within the classroom. Let me try to explain, share another example. Suppose that teacher wrote this equation on the blackboard. This is only this static structure for student. For student, X is wanted to be found. However, when we ask to write a verbal problem reflecting on this equation, then the environment became suitable for social construction of knowledge. Then it begins to be discussed together how to find a verbal problem suitable or reflect this equation. By associating this equation with daily life, the related verbal problem is tried to be established by using the structure of the language. The best verbal problem that reflects the equation is tried to be constructed within this during that situation. I mean, this process, mathematics, turns into a cultural practice. I will give you the common example also. When the teacher teaches division in fraction, she usually uses this explanation. Write down the fraction in the numerator exactly. The fraction in the denominator is invert and multiply them. This explanation, after making this explanation, teacher continue to give some examples to the student. This process, in this process, student only learn this division as a rule, not this not create a conceptual understanding. After, for example, let me give the example of this. For example, 4/5 and let's say 5/6, and this is the example what a teacher says, and then we get 24/25. But there is nothing here. But in order to start a mutual understanding and common product and share it as a classroom, teachers can ask students something like this. For example, we know fractions, two fractions at something like this. When we sum these two fractions, we are using this process. Why we are doing this? We arrange them in the one unit fraction. So the process will continue like this. Why we are not doing this kind of things? For example, in division, we do this in multiplication. We are using the same operation among numerators and denominators, and then we are getting 20 over 3. Why we are not using the same process in division when we have this one? This is creates good conversation between students and teacher. And what we did in addition operation, we transform the fractions in terms of unit fractions. Therefore, we can do the same things. Therefore, this one became like this. And so if we continue, we are using the same operator among numerator and denominator. So, that is why, as a result, 24 over 5 divide. So this one, we get this result like this. This simple example shows us that how we can create common product within the classroom. I would like to give the main meaningful learning product was created together in the class, as you see in this example. I would like to give one last final example. Without collaborative environments, when working with, individually, a student does the operation 2 plus 3 equal 5, while converting the rational number into the decimal number. Suppose that students create or construct this kind of process while converting fraction into decimal. If someone does not show the counter example of this process, this individual construction continue to be sensible, valid construction for him until aware of his own misconception. Why I am giving this example? This is against the Piagetian radical constructivism. From Piagetian perspective, this process is individual construction and is meaningful to him, but actually it is not correct. On the other hand, if this student had done such operation in the group or within a collaborative environment, he would have encountered an opposite example there. When someone in the group asked him to convert 3/2 instead of 2/3, and when he used the same procedure and then put 0 on it and then make this result, someone will ask him that, okay, you convert 2 or 3 as 0.5 as a decimal, and again you try convert this one also. This means that 2/3 equal 3/2. At this case, in this case, he will see his contradictions. A counter example, 3/2 in the same process, it will be 0 point, and he will see contradiction. I mean, Lakatush word, the student can be aware of logical invalid of translation process only by someone's opposite examples. This will also possible to throw whole classroom rather than group work. As can be understood from the explanation and examples above, public artifact is the main characterization of constructionism. In other words, shared ideas, comments, solutions, suggestions, products are the public artifacts. In here, what Peppert says here, that is a transformation from theory to practice to mental construction rather than physical construction. Therefore, the best way in the development of cognitive structure is to participate in the construction process of public works. For Peppert, the student learns the students learn to learn while sharing their ideas. Therefore, students knows what to do, what to explain, what to illustrate, and what to show while sharing. All these actions require the individuals to reflect on their own learning. In the other words, shared ideas, comments, solutions, suggestions, products are public artifacts, I said. I will finish in 5 minutes, okay? As it is thought, the basic characteristic of Piaget's constructivism is not group work, because Piaget's theory emphasized the realization of individual signification, is focused on the individual construction of the work, emphasized the learner is responsible for their own learning. On the contrary side, for peppers, effective learning takes place by sharing the learning product. For example, game-based learning through cooperative play, not individual play. Because for that reason, effective learning takes place by sharing the learning product. Game play with at least two people. Dolayısıyla that is why game is not individual play. Okay. Pepper focus on how knowledge is formed and transformed in certain contexts, how it is shaped and expressed through different communications. And he introduced many tools while constructing knowledge and collaboration, facilitator, sharing and contents and tools, and today's is very important, social media, all of them helping this process of constructing knowledge. As a result, let me give some example from mathematics. Mathematical knowledge is not an object independent of the student, ready to be packaged in the textbook or waiting for us in somewhere to be explored. We examined the explanation of social constructivism and social constructionism. About effective learning takes place from different dimensions. We discussed the constructionism as a collective constructivism offers more effective learning environment and opportunity than radical constructivism because of its emphasis on learning through collaboration, building a meaningful product together, and sharing this product using different tools and media. The teacher who uses constructionism as an epistemological and pedagogical approach takes on a reflective role in their class and transforms classroom learning from individual learning to collective learning. The sharing of group work on problem solution in front of the classroom is an example of this organization. As I said before, of course, in order to create a collaborative, collective product, it is important that teachers encourages group discussions before the solution and interpretation are presented in the front of the classroom. After this, it is time to share the product produced by the groups in front of the class. In this process, discussion and compromises or negotiations will continue on the solutions, comments, ideas, suggestions provided as a scaffolding by teachers on others. Therefore, the collective product will be finalized and shared at the end of this collaborative environment. Now, how do we move a classroom, I mean a traditional classroom, where transfer to a collaborative environment? The question is this: how do we move a classroom, that kind of classroom, where lessons are conducted in this way, into a virtual environment? This is the most important question that we should consider the answer and practice it today. Actually, this question is the question of how do we integrate such a classroom with information and communication technology. I think I used my time properly. This is all from me. Thank you for listening. At the end, I think this is the summarize what I am trying to tell us. Good deeds grow as they are shared. Thank you.
Thank you very much, the Professor Adnan Baki. It was really awesome. Thanks a lot again. And before the leaving for the parallel sections, dear professors, if you have any questions, and I think we can take the one, maybe two questions, since the 6 p.m. after 7 minutes, our parallel section will start. Is there anyone who wants to ask questions to dear professors? Is there someone who have questions?
Teşekkür ediyoruz Adnan Hocam güzel sunumun için. Çok sağ olasın.
Thank you. Teşekkür ederim. Tabii ben şimdi katılımcılara da baktım. 5-6 tane yabancı var. Diğerleri hep Türktü. Tabii tuhaf oluyor tabii şeyi. Bir de biraz teorik bir şey seçtim. Yani bunu bir başka dilde bu şekilde derinleştirerek anlatmak oldukça zor. Belki sizde doğrudan ilişkili olan kişiler belki daha kolay anlamıştır ama umarım bir mesaj vermişimdir.
Thank you very much. And it seems we don't have questions and enough time for that. I want to thank the dear Professor Adnan Baki. Thanks a lot for accept our invitation and being here. And good to see you. Thanks for your all support.
Thank you.
If you want to say something, last word, please.
Thank you. It is my pleasure to be with you. Thank you.
Thanks a lot. Now, our guest, we will continue the other presentation. And now I want to leave my word to Selim Yavuz. He will explain what the next step, I think. Thank you very much again. Have a good evening.
Thank you very much. Thank you very much, Professor Dr. Adnan Baki. I would like to share our programs. We already put in chats for today's program, but just for let you know what can we do. And we will start directly. The rooms already opens and hosts are waiting you. You just need to click in the programs, like for parallel session 1, these links, and parallel session 2, these links, and parallel session 3. If you want to change the rooms, you just need to sign out and click again the other links. And we will have also break rooms for meetings. Maybe we can socialize in there and meet each other in just 10 minutes after the parallel sessions, part 1 parallel sessions. And then we will start again part 2 parallel sessions, and we have 3 parallel sessions in here too. And then we will have 10-minute breaks. And after that, we will have panel 4, online learning and teaching mathematics. And we hope you will be there, all of you. Thank you very much. And we can pass the other sessions.